Here we're going to look at how to solve a one variable inequality by graphing. So we're asked, how can you use a graph to solve an inequality? And in part A, we're told to solve x squared minus 4 is greater than 0. Little statement here, to solve the inequality, identify the values of x that make the value of the expression x squared minus 4 greater than 0. So similar to what we did before when we were solving an equation by graphing, what we want to do is we want to type in this case, we're going to do x squared minus 4. For this specific problem, you only need one equation because you have a greater than or equal to 0. So that basically sets us at the x-axis. We'll get into that in a second. But we can go to y equals and type in x, use the x squared key, which you can find on the left side in the middle, and then subtract 4. So again, this one is kind of convenient for us because we only need to type in one equation. If I hit graph, I'm going to see this parabola, which has been shifted from the parent function down 4. So again, that gives me a good idea of what my graph should look like. To get the specific coordinate points, we want to hit second and then go to graph or table. My graph goes all the way to -5, so that's where I want to look to start, but -521 definitely doesn't fit on my graph. So -412 does not work, -3,5 is a good starting point. So we'll plot -3,5, -2, 0, -1, -3. Again, if you want to pause that to see those points a little bit better, I'm going to run through the rest of them so that we can save ourselves a little bit of time. All right, so now that we have these 7 points graphed, we can form the shape of our parabola. And we want to have that little curve on the bottom. It shouldn't be too pointed. We have a parabola, so there should be some type of curve on the bottom there. All right, so easy part has been done. We have our graph. We know what the parabola looks like, so that is taken care of. Now, to solve the inequality itself, we want to look at the values that are positive. And the reason is that right here, we're looking for expressions or terms that are greater than 0. If you remember when you learned about positive and negative intervals, everything above the x-axis was positive. Those are positive intervals, and anything below the x-axis would be a negative interval. So for this specific problem, this piece on the left here is positive, this piece is positive, and this lower half, or this lower piece, is negative. Since we're looking for greater than 0, these two pieces are going to be our solutions. Okay. So we'll call this, I'm just going to label this as 1 and this piece as 2, so we can talk about how they're set up. But in that first part, again, we're looking above the x-axis because we want positive values. If this was a problem where x squared minus 4 was less than 0, we'd be looking for the negative values. But for that first portion on the left here, we have an x-intercept of -2, and the graph continues to go left to -infinity. So that graph goes from -infinity to -2. And another way to state that, to talk about those values, is that we need everything that happens to be smaller than -2, right? Because -2 backwards to -infinity. So we can say that x has to be less than -2 for, again, that specific piece. And then if we look at the second part of our graph, where we've labeled this number 2, we have an x-intercept of 2. So this is positive from 2 moving right to infinity. That's a pretty bad infinity symbol, so let's fix that. Not much better, but we'll take it. And this time, we're going from 2 to infinity, so we want the numbers that are larger than 2. So for this specific problem, we would say x would be greater than 2. So the solution, how can you use a graph to solve an inequality? And they're asking us to solve x squared minus 4 is greater than 0. Well, the solution is x is less than -2 or x is greater than 2. Because we have those two portions that are both in the positive part of our graph. They're both above the x-axis, so they are positive intervals. Now, this is a problem you probably could have done by hand, solve this inequality without graphing, but it's always good to have options because sometimes graphing will be much easier and other times solving inequality algebraically will be easier. But options are good for us. All right, so now let's look at part B. We're told a motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour, and when will the car be ahead of the motorcycle? All right, so to solve, we need to determine when the number of miles the car travels exceeds the number of miles the motorcycle travels. All right, so we need when the car, we'll say just the car, we'll keep it simple, is greater than the motorcycle. All right, so again, we're talking miles, but just for simplicity, we're going to say car is greater than motorcycle. So the car travels at a rate of 60 miles per hour. So to determine how far that car has traveled, we could do 60 times x, x being the amount of hours traveled. And we want this to be greater than the motorcycle, which is traveling at 40 miles per hour, so 40 times x. But the motorcycle also has a 40-mile head start, so we need to add that 40 miles in. Okay. So this is the inequality we're going to graph. And for our graphing purposes, we're going to use y1 as 60x and y2 as 40x plus 40. So we're going to graph this just like we did the equations, but we're going to interpret the answers and the solutions in terms of an inequality. So you'll see what I mean when we get there. So y equals, let's make y1 60x. And let's make y2 40x plus 40. So 40x plus 40. Let's keep this color-coded. There we go. So there's two things we always look at. We want to look at the graph and we want to look at the table. If I hit graph, I get a graph that looks like this, which does not look very useful. And I'll get into how to fix this in a minute, but sometimes we don't need to fix this. We can just go right to our table and start pulling some numbers. So what I'm going to do is I'm going to pull some numbers here to plot this, and then we'll talk about how to actually fix this graph to help us a little bit more. So on our table, let's start with 0, 0 for our car. After 0 hours, we traveled 0 miles. 160, so let's plot 160. We want to make this as accurate as we can. 2, 120. Obviously, we're drawing this by hand, so it's not going to be perfect. 3, 180. Again, if you want to pause this to copy the rest of the points, I'm just going to run through them. 4, 240. I'm not going to run through them that quickly because I have to zoom in and out here. 4, 240, and then 5 and 6 are going to be off the graph, so I'm not going to worry about those. So I can connect these, and I now have the equation drawn for the car. For the motorcycle, I'm going to do the same thing. I'm going to start at 0. This time we have 0, 40. Sorry that the screen keeps jumping. 180, so 1 and about 80. 2, 120. Notice that that's a point that we've already used, so kind of want to highlight that. This probably has something to do with our solution, or at least finding our solution. 3, 160, 4, 200, and 5, 240. So this one looks like this. Now, one of the things you want to keep in mind, take note that I did not put arrows on the left side because we don't go into the negatives here. There's no negative mileage, there's no negative time. So the graph just stops at this point here. All right, so now that we have our equation, or sorry, our graph, we have this graph, and we want to figure out when the car will be ahead of the motorcycle. Sometimes math can be really complicated, and sometimes it can be really simple. Well, if your graph, let's say the blue one, once the blue one is higher in terms of on this graph than the red one, that means it's greater than it. So if I look at this blue line, it is greater or higher at this portion right here. It crosses here at about 2, 120. We said that already. So what that means is that at 2 hours, the car catches up to the motorcycle, And then anything past 2 hours, the car is going to be ahead of the motorcycle. So the question, when will the car be ahead of the motorcycle? We can say anytime after 2 hours, the car will be ahead of the motorcycle. As an inequality, you could just say x is greater than 2. So going back to the graph, if we look at this portion down here on the bottom, that blue line is below the red line. So it's when the car has traveled a less distance than the motorcycle. Again, sometimes math can be really complicated, sometimes it can be really simple. So just keep that in mind. If the graph is higher, it's greater than, lower, it's less than. There will be times where that's very clear, and there will be times where that's a little more complicated to see. It'll depend a lot on the functions themselves. So I did mention having to take a look at this graph. One of the cool features that you can use on the graphing calculator is you can change the kind of the window that you're looking at. So what you can do on the top, you can click window here, and the x min and x max are along your x-axis. So what I can do is, if I look at the graph that I was given in this problem, so if I'm looking right here, my x values go from 0 to 6. So I'm going to change my x minimum to 0. My x maximum is going to be 6. My y minimum goes from 0 up to 250. But the y-axis jumps by 50 each time. So I'm going to make the y scale. I'm going to turn that into a 50. And now if I hit graph, notice that we have a graph that looks quite similar to what we've already drawn. So you always have the option of changing the window to kind of better suit your needs for this graph. You won't know exactly what point. You'll have to use some other features, and you can use the table or some other of the tracing features, which you'll learn pretty soon. But for now, just know that you are able to go to window, and you can manipulate and change that window to suit your needs for the problem. All right, so that's it for solving inequalities. You have two options. Option one is where you are looking above or below an x-axis because you're looking for greater than or less than 0. And the other one is where you're going to compare two lines and see which one is greater or less than at a given point. All right, so that's it, and we'll move on to the next question.